Question 9 of the Calc Knowledge pretest says that an arrow shot up from the moon at 80 meters per second, and its height in meters is given by this equation. The first part of the question asks, what is the velocity of the arrow after 10 seconds? Well, we know that this equation models the position of the arrow from the moon at any given time. And since we have a position equation, we know that the velocity is equal to the derivative of this equation, which is 80 minus 1.8 t. And to find the velocity at time 10 seconds, it's equal to the derivative at 10 seconds, which is 80 minus 1.8 times 10, which equals 62 meters per second. So after 10 seconds, the velocity of the arrow is 62 meters per second. So part B asks after how many seconds will the arrow hit the moon? Okay, so let's look at the graph. So the arrow is traveling as so. And this kind of reminds you of a parabola. Well, we know that at the starting position, before the arrow is shot up, the position of the arrow is at 0. And when the arrow comes back down to the moon, it's going to be at 0 again. So we know that when the position of the arrow is 0, we can find our t. That's when the arrow is going to hit the moon again. And this should remind you of a quadratic formula. So let's just rewrite this in a format that looks a little more familiar to us. And now that we have it in this formula, we can find t by the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just plug in those numbers. Well, after completing all this math, we get that t equals either 0 or 88.889. And this makes sense. At time 0, the position of the arrow is also 0 because it hasn't left the moon. And after 88.889 seconds, the position will be 0 again because the arrow hits the moon again. So let's just save this time because this is going to be important for the next question. So part C asks, what is the velocity of the arrow when it hits the moon? Well, we remember that the velocity of the arrow is equal to the derivative of the position, which is 80 minus 1.8 t. And we now know the time it hit the moon, so we can just plug that time in to find the velocity at that time. And we get that the velocity is equal to negative 80.0002. And the velocity is negative because the arrow is hitting the moon in a downward motion.